Hello and welcome to our Tips and Techniques videos. I'm Mark Biasotti and we are currently in our advanced modeling episodes. And over the next 30 minutes or so, we'll be exploring how you can increase your skills using some of SolidWorks' more advanced features so that you can be more productive and create higher quality models. So whether you're a seasoned SolidWorks user or a beginner, we think that you'll learn something new in this series. For your convenience, we've listed the topics in the YouTube description that we'll be covering in today's episode, along with a timestamp for each topic in the video. Feel free to skip ahead to any tip or point you want to learn more about. This series is being brought to you by Spanner Product Development, a product development company dedicated to creating positive impact in the world, merging innovation, sustainability, and responsibility to bring meaningful experiences to life for over hundreds of clients. If you want to learn more about what Spanner has to offer, stop by our website at spannerpd.com or email us at hello@spannerpd.com. Now let's get started with this episode of our Advanced Modeling episodes.
When applying fillets for product design, it's good to keep a flow of the fillet, and this really aids in when you have reflections and glossy surfaces to really look aesthetically much nicer. And it has a lot to do with fillet order. It has to do with the way the fillets are applied, and in some cases it can make a big difference. Here it's not too bad, but if you get some reflections coming in on the top of the side, you can see that you're getting kind of a pinched corner. So we want to take a slightly different approach and use another option in fillet to rectify that situation. So if we go back into our fillet here and roll down in our property manager to an area called Set Back. Set Back gives us the ability to set back corners with a patch, with a transitional patch. So the way it wants to know how to do that is it wants to know the selection of the vertices where edges are meeting. So you need to make that selection, and I'm going to pick these two corners here. And then you can start to set these values individually. For the sake of time, I'm just going to put in a value, something like 13.7, and set all and see what we get. So we get some setback that looks something like this. Now, it's kind of interesting with Instant 3D on. You can actually start pulling on these values and start to play with it to tighten it up a lot. And that's what I want to do here. Actually, that was pulling my radius value. I want to highlight it again and pull this meatball up a bit. Let's get it a little tighter. So let's get it so it almost pinches, but not quite. So let's come down here and then take a look at that. So we get the ability to use the offset of the corner to get a much nicer transition between the three when using setback. So that's how setback works. So moving on to some more advanced cases, and particularly cases where it is difficult to apply fillets. Let's take a look at this model, which has a number of examples in kind of troubled areas. So I'm going to want to fillet a lot of these intersecting edges between the handle and this one half of this object. So I'm going to start picking these fillets. Let's bring it something down to like 2. And then as I continue to pick other edges, it's not going to fillet, and we know that because there's no preview. Now, in this case, what's happening is that because these three edges where the fillet edge terminates are tangent, it really can't understand or figure out how to fillet this edge and then transition to this edge. And this is a common case when you have intersecting cylinders and shapes like this where no matter how hard you try, you're just not going to get a desirable fillet transition between those edges. So let's do a few creative things to make that happen for us. So I'm going to unsuppress the solution. And if we turn off our tangent edges, this is what it looks like. And this is the kind of result that I want between these two parts of the body and the handle and this area. So I'm not going to go through all the solutions. I'll talk about this one and maybe a few of these. So let's take and roll up through our solution. So the first thing that I need to do is I need to isolate the problem from the actual fillet feature. And one way of doing that is by using what is called the Atomic Bomb Fillet, which is known in the SolidWorks community as a old-time favorite. I can't remember who actually had created that term and first showed it, but whoever they are, they're brilliant. So what I am doing here is that I'm just creating a simple sketch on the right plane and then splitting these faces out. Now once I've done that, then I can delete those faces. It's a surface body now. But what that allows me to do now is to apply a fillet between these surface faces and not have it get confused at the termination point that we had before. I've stopped short of it with the split and the delete face. Now you can see I've done that on both these edges, and I've actually applied different values to each of those edges. And now with that, we can use our fill feature to fill the area back in. And when we fill it in, we're using a quick selection loop, and then we're also merging and creating solid again. So very quickly you can get back to the kind of solution that we want. Now with edges on, it looks a little bizarre, but rest assured, this is all tangent. And with tangent edges off, you get something that looks like this. Now I've done the same thing as we move forward, turn edges back on, and we do some fillets here, do some split lines here, apply a face-to-face fillet with a hold line there, and then we're putting another atomic bomb split here, deleting that face, and then applying these three fillet edges separately. And then once I have those, I can fill that in and make it solid again, and then knit it all up, and then of course mirror it over. So that is how you get around those tricky fillet intersection problems. Here's another situation where filleting can be hard to apply to SolidWorks models, and it usually occurs when you're applying a fillet to multiple edges, and the fillet has to convert all of a sudden from a concaved fillet to a radius, that is from concave to convex. And it has a lot of trouble trying to figure out how to do that, especially around this vertices. So let's just try that. It does work, and SolidWorks is pretty smart if you pick all of the edges. So let's make this 1.5, and let's keep going with similar values. And it usually works if you pick all of the intersecting edges. And so you'll get something that looks like this. Now the limitation is that it's only one fillet type. And say for instance down here I wanted to make this chordal width going down. I can't do that because this is just a constant edge fillet with multiple selections. If I turn on multiple radius fillet, I can make these different values and continue my work. But again, I can't get variable fillet or face-to-face fillet down here. So that is one solution for doing that. Remember, you can also clean up these corners here using delete face with its fill option. So going from its default delete or delete patch, go down to delete and fill with tangent, and just pick these so that your resultant is a singular patched face. Like that. Okay, so that's pretty acceptable solution, pretty nice. But again, if I need to do something where these are different fillet types or I need to apply them separately, this isn't going to work. So let's take a look at a second solution. Actually, let's take a look at this first solution and see what this is about. So this again is just what I did, where I'm applying one fillet with multiple values and doing the delete face. So we've covered that. Let's take a look at the second solution, which I believe is a little bit more creative. And this one is using split lines to delete the ambiguity around these points here. So what I've done here is I've done a single split line or two split lines. I found out you can't do them at the same time because of the closed loop. But I've done the split lines, and then I do a delete face on these areas, and then I can apply my fillets individually. And this is what I want, because I want these to be different fillet types, especially this lower one. If I wanted to apply that as a face-to-face fillet, I can do that. Let's just delete that and try that. So I know we're going to have some failed features down the line here, but let's go ahead and create a fillet by face between these two, and then let's try to do chordal width, and let's make that something like 1, and let's reverse our arrows, see if that works. Okay, for some reason that's not going to work in this example model, so let's just undo back to what we had and keep going. I'll investigate that for a future episode. So the next step would be to do an untrim on what was existing here, or what was trimmed away. I want to trim it back, so especially this upper edge, I want that to be constant again. So basically I'm taking these edge selections, I'm saying extend it back to its untrimmed state. And that's what it was. And then with that, I'm going to do a bit more cleanup using split lines. So I'm going to use some additional split lines from the top plane. And I'm going to create some very simple 2-point splines, make them tangent to these edges. And the intent there is to then split those out as faces and then do a delete again on those faces. So now we have a nice clean transition that I want between especially this upper fillet and this outer fillet edge. Then it's just a matter of doing a fill feature on this first one using merge. And then on the second one, I'm going to just do another fill feature. If I can turn my model here. I'm doing a fill feature and using the shortcut merge and make solid again down here. So I like that solution better, aesthetically at least. And so that's the way of getting around that particular problem where you have vertices that's shared by common edges and the fillets have to actually invert. Now there's certain situations where full round is not going to work. Let's just say that these are some interior ribs and I need to put a full round on the top of all these ribs. Well, the full round feature is not going to work here. And I can try it just to make sure it's not going to work, because it can't migrate that full round to these other faces. the fact of the matter is that it probably would work if I pick all of these faces. Let's go ahead and try that. And see if I can get something that does work. No, it's not going to work. It's just, there's just too much going on. And the fact of the matter is that my selection is wrong too, because this really needs to be opposing faces instead of all these exterior faces. So it's just not going to work. So we find other ways to do things. One way would be possibly creating a constant round fillet on one side and then on the other side. The problem with that is you have to know what that value is. And if we just simply measure this, we can see it's 10 millimeters. Well, I applied a 10 millimeter radius down here, and it's still not meeting at an apex at the top. And that's because of the draft on either side. So that's not going to work very well either. And it's not going to work very well even if well, especially if we start changing our rib thickness. So if we go in here and I have all these ribs tied together with a common value, if we make that something like 7, let me try that again. Take it off of its equation or global variable. I think if I rebuild, it should work. Yeah. So you can see that that's not going to work either. It's not very parametrically robust. So I think the way that I would do this is take another approach. And again, you might guess it has to do with using split lines. So let's go ahead and change this back to 10 and do a rebuild. And so this is my solution to when I run across things like this. Let's go ahead and unsuppress this. I'm running out of time for this episode, so I think I just have to walk you through this. So what I'm doing is I'm creating some split lines that bisect the top landing of each of these. So I do one split line here. I do another split line along this back edge. I do another split line here to give a landing between these 3 ribs, and I do the same over here. Now with that, what you can do is start to use a face-to-face fillet with a hold line. And so what I'm doing is using these as one face, then the top face, and then using that split as a hold line. And I do that with the remaining areas that I need to actually put my full round fillet on. And the nice thing about that is now if I change my global variable to something less than 10 or something greater than 10, let's make it 7, this should survive. Sure enough. So that works. And that's a good way of when you can't do a full round, you're able to apply something that's like a full round using a hold line. Now sometimes, no matter what your fillet order is or how you try to reorder fillets, you just can't get around this problem where you have a transition between 3 different fillets that ends up with the vertices. So in this case, what I'm wanting to do is create a 15 millimeter fillet here and then apply a constant, or I should say a face-to-face fillet with chordal width at the bottom, and then doing another constant fillet at the top. And using 3 different fillet types, I can't get a transition here. So the solution, you guessed it, would be to use an Atomic Bomb technique, which I remember now, I think came from Keith Peterson many years back at a SolidWorks World when he presented it. Fortunately though, with a new feature that came in SolidWorks 2019, we no longer have to use that method. And I think using the fillet partial edge option is going to make fillet solutions like this more robust. And let me show you what I mean. So let's go ahead and just delete these fillets here. And let's go ahead and show our solution. So this is a solution that I'm looking for, is to do just a really nice transition between this side edge fillet and this 15mm fillet. And I'll show you how that was done using this new feature. So one of the problems that can present itself with the Atomic Bomb Fillet method is that you have to eventually get to a point where you delete faces and turn your solid into a surface body. At some point you apply your fillets and then you create a fill patch and turn it back into a solid. I don't like to, let me say this, I try to avoid going from solid to surface to solid to surface and try to not do that, because when that occurs, then you're passing along the body ID to a surface ID and then back to a body ID. That can make features fail down the line, especially the split feature, the save body feature, and if you're inserting bodies into other derived bodies, it'll certainly fail. So I guess what I'm getting at is a slightly different method on that. So it's still the idea that you would isolate the corner from the fillet, not understanding how to do the transition. So here I can do my face-to-face with chordal width at the bottom, but the difference is then when I start to apply these fillets, I'm using the new feature in 219 called partial edge parameters. And here you can use it with a reference point. I have a sketch reference in there that's being driven by a dimension. You can also use some other options, as I did here on this second fillet, this 15mm fillet. I'm using just a distance offset, which is probably the right way to do it parametrically, because this point's not going to change very much. And for this pocket to change, you want the distance to be pretty much set between here and the start of this radius. So with that, using this new feature, partial edge parameters, I then get a portion of my model looking from the top view where I can create some split lines. And then it's just a matter of creating some pretty simple spline, 2-point splines between where these partial edge fillets ended. If you want your model to be a bit more robust, I would probably recommend over a 2-point spline to do a conic here. The reason for that is that with a conic, it can be driven by one dimension and it'll stay fairly consistent as it scales between these features that might change in your model. Let's go ahead and make this tangent, and let's go ahead and make this tangent. Ignore the over-constrain. That happens when it's a bug, basically, when you put a conic on a spline. The constraint over-constrains. So I'm just going to take this and use my replace sketch entity for this, and then I can assign my row value, make it something like 0.675, and then split my surfaces. So now with those surfaces split, I don't need to create a fill feature or delete these faces. I could just go to the delete face feature with the delete fill and tangent fill option and apply that to all these split faces, including the ends of these partial end fillets. And I get a pretty beautiful transition there between those. And so that's the way to solve that particular situation.
Thanks for tuning in to today's episode. We hope what you've learned has been informative and can help you to better use some of SolidWorks' advanced features. You'll see in the YouTube description a link to example models used in today's video. Feel free to download it, and you can explore these techniques at your own leisure. Also, we'd love to hear from you, so consider emailing me at the address you see here on the screen. If you need help on your design project or just want to know more about us, stop by our website at spannerpd.com or email us at hello@spannerpd.com. Take care, and I'll see you in the next episode.